Alrighty, we are back. This is your last lesson with limits. So we're just going to do some more practice with limits, evaluating functions from the left and the right hand side, limits to infinity. So let's just get started. Now this should be review, guys. We've talked about all of these different concepts, and I have a mixed array of problems here. We're going to deal with some factoring, multiplying by conjugate pairs. Oh, it's gonna be fun. So first problem, the first question it asks is find f of 0. So that's when x equals 0, we want to know what does y equal. So as I come over here, well, here is where x would equal 0. Now, there's a hole here. There's no actual point there. So we're going to say this would be undefined. On Delta Math, it likes to use undefined for the points, for example, like where the holes are, whereas does not exist, we use in reference to limits. Okay, so f of 2, let's take a look. So for f of 2, when x equals 2, so that's here. When x equals 2, I have a y value of 0. When x equals 3, so when x equals 3, there's a hole here, there's the point at 3. And now the limit as x approaches 0 from the left, so that 0 is their superscript from the left. So I'm going to start to approach 0 from the left. And we're looking at this. So from the left, approach 0, get closer and closer. We're approaching negative infinity. And now as I just approach 0 in general, which means this is including the left and the right hand side. So from the left, we go to negative infinity. From the right, we're going to 2. So we would say here the limit does not exist. You're approaching two different y values. The limit as x approaches 3 from the right, notice that superscript of the plus. So we're going to approach 3 from the right, and we're approaching this y value of 2. The limit as x approaches 3. So as we approach 3 from the left and the right, we're approaching two different y values. That's a jump discontinuity, so we say the limit does not exist. All right. And the limit as x approaches negative infinity. So now we want to approach negative infinity. So we're going to be going in this direction. As we approach negative infinity, you can see there's this asymptote here. So let me erase this. So we have the asymptote, which is getting really, really close to 1. All right, and then you guys have it for that first example. Just a few things I want to point out. We have jump discontinuity going on here. All right, we had to actually jump to get from one point to the other on this graph. So there's your discontinuity. Alrighty, let's take a look at question 2. Why don't you guys try this on your own now that I went through the first one with you? Try the first one on your own, and let's see if we get the same answers. All right, so these are my solutions here. I have f of 0 is 0, so there's 0 when x is 0. F of 2, well, there's no actual y value at 2. We approach positive infinity and negative infinity. You actually have an infinite discontinuity here. F of 3 when x equals 3. So when x equals 3, that is here. We're at 0. The limit as x approaches negative 1 from the left and the right. Again, you have an infinite discontinuity. You're approaching infinity and negative infinity. So the limit does not exist. The limit as x approaches 0, we already said here, well, f of 0 is 0. And as I approach 0 from the left and the right, we're approaching 0. So that checks out. The limit as x approaches 2 from the right, so we're going to approach 2 from the right. So that's this direction. We're going towards negative infinity. And then the limit as x approaches infinity. So as we approach infinity, we've got that horizontal asymptote here at 1. All right. So make sure you have the same solutions here as me. Again, just a reminder, Delta Math uses undefined for where the points don't exist. And then for the limits, we use does not exist for DNE. Alrighty. Okay, let's take a look at question 3. There's a few parts here. We've got parts A, through D. So let's start off with the first one, and then you guys are going to practice and do some of these on your own. So I'll do the first two with you, letters A and B. You guys will do C and D on your own. So first things first, I always look to see if I can substitute right in, which is what I'm going to do right now. So let's substitute in. I have 0 squared minus 25 all over 0 squared minus 4 times 0 minus 5. Always go to substituting in first, guys. It's going to save you time. So I have negative 25 over negative 5, and I end up getting 5. So it actually worked out. I didn't need to factor anything. I was able to just do direct substitution, and it worked out nicely. Okay, let's try letter B. Again, I'm going to go with that direct substitution method. I've got a value to plug in, so let's see what happens. We'll have the limit as x approaches 5, and we're plugging in 5. All right, so I'll have 5 squared minus 25 all over 5 squared minus 4 times 5 minus 5. I end up getting 25 minus 25 all over. This is 25, this is 20, so this is 5. 5 minus 5, and oh, that's indeterminate form. So direct substitution didn't work for us. So this is not going to be our best method of choice. So what I'm going to think to do instead is to factor. All right, so let's factor this. I have the limit as x approaches 5. Remember, don't drop the limit. You only get rid of the limit once you've actually started to plug in. I'm going to factor this because this is dots, our fave. And this is what we got going on the bottom. All right, so hopefully we're pretty speedy with our factoring here. And these are going to cancel out, telling me that there's a hole. So that's just a little side note. There's a hole at x equaling 5. All right, that's good to know. That's why we get that indeterminate form of 0 over 0. And let's start to simplify. So now I have the limit as x approaches 5 of x plus 5 all over x plus 1. We're going to plug in now so the limit goes away. And we are left with 10 over 6, which simplifies to 5 over 3. So 5/3 is my final answer for B. Why don't you guys give questions C and D a try? I'll post my solutions, but give those a try on your own. All right, so here's just some of the work I did just so we know how to factor the top. So just so that you have that to follow along with, I'm going to erase this and I'm actually going to now write out my full solution. All right, so there's my final worked out solution for letter C. We also had to multiply the A term to the C term to the back. So if you like to use tricky trinomial here, go for it. I used factoring by grouping. I split my middle terms. This is what I ended up getting for the denominator. After factoring it out, simplified, I plugged in using now direct substitution after factoring, and I got 10 over 2, which is 5. Alrighty, letter D. Try it on your own, and I'll post my solutions again up here. Alright, guys, there you have it. For letter D, you should have gotten an answer of 1. You end up getting 4 over negative 4 times negative 1, which is really 4 over 4. And your final solution is numero uno. Alright, let's take a look at question 4. Up in the difficulty just a little. Now we're starting to get really more mixed problems here. So for question 4, letter A, you should be paying attention to that radical. And if you remember in one of our earlier lessons, when we had that radical, very first thing, you always want to apply direct substitution. And if that doesn't work, then we're going to multiply by the conjugate to get rid of this radical in the numerator here. So first, let's do this with direct substitution. If we end up getting that 0 over 0, we got to try another method. Okay, so let's plug in. We're going to plug in, so I don't need the limit. I have the square root of 3 plus 1 minus 2 all over 3 squared minus 9. I end up getting the square root of 4 minus 2 all over 9 minus 9, and that is 0 over 0. So, okay. I mean, I could already tell just from looking at it that direct substitution wasn't going to work, but I just want to make sure that you guys are applying that first when you have the limit going towards a numerical value. So here in this case, it's 3. We wouldn't be doing that if we were looking at B and C because those are going towards infinity and negative infinity, so that wouldn't work. Okay, so now let's apply another method. So now I'm going to apply our method of multiplying top and bottom by the conjugate. So we're going to multiply the top by square root of x plus 1 plus 2 all over square root of x plus 1 plus 2. Again, we're allowed to do this because we're multiplying really just by a form of 1. So we're going to write this out as the limit as x approaches 3. I'm going to do my double distribution here. So let's actually multiply this all out. Okay, so I just wrote out my steps here. I'm not going to multiply the bottom. I'm going to leave it as is. Okay, so I noticed that these middle terms cancel. That's the whole point. And now I'm going to rewrite this as the limit as x approaches 3. We can simplify here. This is going to be x minus 3 all over. I can factor the bottom. I'm not going to double distribute, but I can factor the bottom. We have that plus 2 as x minus 3 and x plus 3. So you'll notice that these cancel. And now I'm left with the limit as x approaches 3 of 1 over x plus 3 times the square root of x plus 1 plus 2. All right, and now I'm just going to plug in right now. Now we can do our direct substitution since we've simplified as much as possible. We'll be left with 1 over 3 plus 3, that's 6, times the square root of 4 plus 2. So really this is going to be 4. So I have 6 times 4. So this is going to end up being 1/24. That's my final answer here. Awesome. Okay. Why don't you guys try letter B? Notice now we're talking about limits to infinity. All right, so we're going to try letter B, and you guys are going to do C and D on your own. So I actually immediately noticed this is top heavy. So we actually are only going to pay attention. Remember, when it's top heavy, we take a look at the leading terms. So now we're going to be looking at the limit as x approaches infinity of x to the 4th all over 4x cubed. Remember, we take the limit to infinity, and it's top heavy. Take a look at the leading terms. We're going to simplify this. The limit as x approaches infinity of x over 4. So really what I'm looking at is infinity over 4, which is still infinity. So there's your final answer there. You could have also tackled this by dividing everything out by that x cubed, every term by x cubed, and you would have still seen the same exact thing. All right, guys. Why don't you guys try letters C and D? So give it a try. I'll do E with you, letter E. So give questions C and D a try. Pause the video here. Okay, so for question C, this one might have been a little bit more tricky. You actually have to pay attention to the fact that this is equal heavy. So I rearranged my terms here. So instead of x minus 3 over 5 minus x, I rewrote this line here as negative x, and then that's a plus 5 here. So I saw that this was equal heavy, so I take a look at the leading terms. This is equal heavy. And I have x over negative x is just negative 1, and the cubed root of negative 1 is just negative 1. So there's my final answer. All right, that one actually was a little bit more difficult. Okay, let's take a look at letter D. So again, why don't you pause the video here, give it a try, paying attention to whether it's equal heavy, bottom heavy, top heavy. All right, guys, and there's your final answer for letter D. So again, I saw that this is equal heavy. Be careful, this was not written in the correct order. So I rewrote it. We know that these terms are insignificant here. Again, I've shown you guys why, because if we divide everything by that x cubed, if I were to divide this by x cubed, divide this all by x cubed, you'd have a small number over infinity, which goes to 0. So those terms will all go to 0 here. And what I'm left with here is if I have x cubed over x cubed, those terms are going to cancel. And I'm left with negative 3 halves. All right. Okay, letter E I said I'm going to do with you. So immediately I noticed that this is bottom heavy. So when it's bottom heavy, we know that the limit is going to go to 0. But I actually do want to do this out algebraically the way I've shown you. So if I have the limit as x approaches infinity, I'll have x over x squared plus 5 over x squared. Remember, we divide out by the leading term in the denominator. So that's our x squared. That's our highest power, our highest degree. So we're going to divide everything out by that x squared term. I'll have 2x squared over x squared plus 1 over x squared. I'm going to simplify this. So I have the limit as x approaches infinity of 1 over x plus 5 over x squared all over 2 plus 1 over x squared. Remember, guys, when you have a term that's going to infinity, 1 over infinity is 0, 5 over infinity squared is 0, and 1 over infinity squared is 0. So what we're looking at now is 0 plus 0 over 2 plus 0, and 0 over 2 is just 0. So again, bottom heavy equates to our function going towards 0. Think about that horizontal asymptote. All right, guys, we are almost done. Almost done. So let's take a look at a few more problems, and we are done with limits. You have finished the year. Please pay attention to these last 4 limits. These are actually really important. Don't skip them. So we are actually going to go through A, B, C, and D. Really important stuff I'm going to show you that we haven't necessarily seen before. So I want to take a look at letter A. We're taking the limit as x is approaching negative infinity. So I'm going to divide everything out by that x to the 6th term. So let's rewrite this. This is the limit as x approaches negative infinity, and we're dividing it all by that x to the 6th. All right, so I notice a bunch of stuff is going to happen here. We can start to simplify this. So we have the limit as x is approaching negative infinity for the cosine of this function. I'll have 1 over x plus 1 over x to the 6th all over 1 plus 1 over x plus 100 over x to the 6th. Remember, this is a limit that's going to infinity. So this is going to go to 0. This is going to go to 0. This is going to go to 0. And this is going to go to 0. So now I'm looking at the limit as x approaches negative infinity for the cosine of 0 over 1. And 0 over 1 is just 0. So we're just taking the cosine of 0. So if I were to sketch out my unit circle here, cosine of 0 is 1. So this limit as x approaches negative infinity is actually just 1. That's my final answer here. Careful because of the cosine. All right. Okay, let's take a look at letter B. So again, I said I'm going to go through all of these with you. Letters C and D are probably the most important limits that I'm going to be covering because, again, it's not something that you've seen before. We're going to be tackling it for the first time here to conclude our year with limits. Okay, for letter B, again, I'm always going to try to plug in with direct substitution because I have a limit going to 2. So I have 2 times 2 all over 2 squared minus 4. And I have 4 over 0. Now, 4 over 0, that's not the same thing as 0 over 0, guys. This is different. This is telling me that I'm undefined. There is several, actually, if you look. I have x minus 2 if I were to factor this, and x plus 2. I've got 2 vertical asymptotes here. So if I were to kind of sketch this out, I have a vertical asymptote at negative 2 and a vertical asymptote at positive 2. Because if you guys go back to when we talked about rational functions, when you set that denominator equal to 0, right, that's where the vertical asymptotes exist. But we want to check when x is approaching 2. So I want to know as x is approaching 2, does my function look like this? Right, that's a possibility. Does it look like this, where they're both going towards infinity? Draw another situation. Does it look like this? I don't know. I don't know if the limit exists. I don't know if the limit's going to infinity. I don't know if the limit's going to negative infinity. So because I plugged in with direct substitution and I did not get 0 over 0, now what we need to do, so we did not get 0 over 0. This would have been that indeterminate form. I ended up getting something that's undefined. Because I got something that's undefined, now what we need to do is we need to check both the left and the right hand limits. So stay with me here. So we need to check the limit as x approaches 2 from the left, and we need to take the limit as x approaches 2 from the right of this 2x over x squared minus 4, 2x over x squared minus 4. Okay, now I am going to make my sketch again, because again, I know that there's a vertical asymptote at x equaling 2, so I'll have an idea of what's going on here. There is one at negative 2, but that's insignificant right now because we're just checking when we approach 2. Okay, now, if you guys think about your number line here, so here's 2. If I'm approaching 2 from the left, I'm looking at a number at like 1.99999, right? If I'm approaching 2 from the right, if I'm approaching 2 from the right, I'm looking at a number at like 2.00001, right? So that's what you need to keep in mind here. So from the left, we're looking at like a number of 1.99999. From the right, we're looking at a number at like 2.00001. So let's think about this. As I approach 2 from the left, so I'm looking at this value here. Well, let's see what's going on here. I'll have 2 times 2. So 2 times 2, that's going to be roughly 2 times, really it's 1.999. That's roughly 4. All over. Now I have this 2 squared minus 4. Keep in mind, this number is, think about it as like 1.9999 squared. So it's going to be a little bit less than 4, right? So I have a number that's smaller than 4 minus 4. That's going to get me a number close to 0 that's negative. So I'm going to get a number close to 0 that's negative. So if I have 4 over 0, something really close to 0, but it's a negative number, this is going to go towards negative infinity. Okay, so right now I can tell that my limit, and I'll reiterate this because again, this is something brand new for us. My limit as x is approaching 2 from the left, so from the left, we are going towards negative infinity. So I can make this drawing here. I know that's what the function looks like because we took a number that's really close to 2, but it's smaller than 2. So if I have a number that's smaller than 2 squared, it's going to be less than 4. And a number that's smaller than 4, taken away from 4, is going to be 0, but it's going to be a negative value. Right? So picture this as something like, I don't know, 3.99 minus 4 is negative 0.01, just as an example. So it's super close to 0. Okay, now let's take a look at the limit as x approaches 2 from the right. So again, we're looking at this number here, that 2.00001. So it's a number bigger than 2, but ever so slightly bigger than 2. So we'll have the limit as x approaches 2 from the right. So we still have 4 on top, because really I'm looking at 2 times 2, which is approximately 4. And now I have this number here, 2 from the right squared minus 4. So this is a number bigger than 4, subtracted with 4. So I'll have 4 over a number that's bigger than 4. So let's just say that that's like 4.01 minus 4. That's going to be positive 0.01. So this is going to be a positive 0 value. And remember, when I have a number on top divided by 0, that's going towards, now in this situation, positive infinity. So if I were to sketch, as I approach 2 from the right, I'm going towards infinity. So that's what this graph would look like. So because I'm approaching 2 different values, I have negative infinity and positive infinity, we would say this limit does not exist. Please go back and rewind any part of this if you guys need the extra practice. We are going to do letter C and D, which are similar problems to this. So if you're a little stuck on letter B, don't lose hope. Question letters C and D, I'm going to go over this again. Okay. So I'm going to erase what I got here and let's take a look at letter C. All right, so for letter C, I'm going to plug in with that direct substitution here. So I'll have 3 times negative 1 all over negative 1 squared plus 2 times negative 1 plus 1. I'll end up getting negative 3 over, this is 1 minus 2 plus 1, and that's 0. Again, notice this is not indeterminate form. This is not 0 over 0. This right now is undefined, which, if you guys go back to when I taught you rational functions, if I were to have factored this, this would have been x plus 1 times x plus 1. That means there are a vertical asymptote at x equaling negative 1. So I'm going to sketch this. So at negative 1, I've got a vertical asymptote, x equaling negative 1. All right, so again, I plugged in my direct substitution. I got undefined, not indeterminate form. I recognize, oh, well, it's undefined. Vertical lines are undefined. I have a vertical asymptote if I were to factor this as x plus 1 times x plus 1, when you set this denominator equal to 0, I've got a vertical asymptote at -1. We need to check what's going on the left and right hand side of -1. Am I looking at a graph like this? Am I looking at a graph like this? There are 3 different options here of what I could be looking at. Actually 4. You could also have this situation going on. Okay, bunch of different options. So we got to take a look at the left-hand limit and the right-hand limit. So I'm just going to erase what I have here to make some room. All right, so we're going to take a look at the limit approaching -1 from the left and -1 from the right. So again, I'll make that little sketch down here. We know there's a vertical asymptote at -1, and I want to know what the graph looks like. What is that behavior? So let's take a look at -1 from the left. So we're going to be checking this way. Is it going this way or is it going this way? We're going to check both. All right, so if I'm taking -1 from the left, so you guys got to think about that number line again. Here's -1. If I'm coming from the left, you're looking at a number at like -1.001, right? If I'm coming from the right, let's draw that in red. If I'm coming from the right, I'm looking at a number at like -0.999. Okay, so right now we're dealing with the left, so that's what I have here in blue. So we're looking at a number at like -1.00001, something super close to -1, but doesn't actually reach it. So if I multiply the top here, I have 3 times -1, well that's just going to be -3. But now I have, and I'm actually going to rewrite this the way I had it before, as that x plus 1 squared. So I'm actually going to do that here. It's going to make our lives a little bit easier when I'm evaluating this limit, and you'll see why in a second. I'll write this as that x plus 1 squared because they're the same exact thing. This is now just factored out. Okay, now I'm approaching -1 from the left, so I'm looking at a number here as -1.00001 plus 1 squared. Well, if I have a more negative number with a positive number, this is going to be a negative value that's really close to 0. So we're going to have a negative value really close to 0. So we'll have a number like 0 to the negative power because we're just indicating it's a -0. And I'm all squaring that. So we're going to write this out here as 0 superscript negative squared. So this is a -0. We're getting really close to 0. So if I have, though, this is being squared, whenever you square a negative number, it's going to end up being positive. So I have -3 divided by a positive 0 now. That's going to end up going towards -infinity. So I'm looking at this bottom portion. As I approach -infinity, as I approach -1, so as I approach -1 from the left, this is what my graph looks like. It wasn't that other one. Okay, let's go through it again. Let's do it now on the right-hand side. So now on the right-hand side, I don't know what I'm looking at. Am I looking at this or this? So let's check. Now, if I'm looking at -1 from the right, now I'm looking at that -0.999. So if I have positive 3 times a negative, essentially -1, well, that's just going to be -3 all over. Now I'm plugging in this -1 coming from the right plus 1 squared. So we have that -1 coming from the right. Well, this is going to end up being a positive 0. It's very close to 0, and it's a positive value squared all over that negative. So you -3 divided by 0 squared. And in this situation, guys, it actually didn't matter here or here, because whether this was a negative value close to 0 or a positive value close to 0, whenever you square it, it's going to be positive. So I'll have -3 over a positive 0, which again, a negative number divided by a positive number is negative. And because I'm dividing by 0, we're going towards -infinity. So this limit actually does exist. We're going towards -infinity in both cases. So my limit as x approaches -1, my answer here is -infinity. You have first found it was undefined because there's a vertical asymptote here. And now we just evaluated further that because both ends are approaching -infinity, my answer is -infinity. Awesome. I would like you guys to give question letter D a try now that I've just explained how to evaluate the limits from the left and the right-hand side. Same exact idea. So if you didn't get it in letter B, still didn't get it in letter C, we've got it for letter D. All right, so for those of you that want to give this a try on your own, definitely pause the video here. For those of you that still had no clue what I was talking about for letters B and C, maybe you want that extra practice, still a little confused, I'll go through it right here and right now. So again, you can pause it or you can follow along with me right now. So I'm taking the limit as x approaches -1. So I'm going to do that direct substitution first. I have -1 squared minus 25 all over -1 squared minus 4 times -1 minus 5. So with direct substitution, I have 1 minus 25 all over 1 plus 4 minus 5, and I end up with -24 over 0. Recognize this is not indeterminate form, so this is not 0 over 0. So I'm actually looking at something that's undefined. Meaning, again, we have a vertical asymptote, and I want to figure out, well, where does that vertical asymptote, what's the behavior of it? Is it approaching infinity? Is it approaching -infinity? Like, what's going on? Now, if I were to have factored this, so we have to make our steps further. We're not just done here at it being undefined. So if I were to factor this, let's check out what happens. I have x minus 5 times x plus 5 all over x minus 5 times x plus 1. Now I notice I actually can cancel here the x minus 5s, indicating there's a hole at x equaling 5. So there's actually a hole at x equals 5. Remember that. But I've still got that vertical asymptote, which is what we would have assumed anyway, because we're checking as the x values approach -1, and there is a vertical asymptote at x equaling -1. So we want to check the behavior of this graph, what's going on. So let's see, let me write this out. All right, so again, at x equaling -1, we want to check, what does the graph look like? You have 4 different options of what could be going on. We could have any of the ones that I'm writing out here in blue, and yellow, and red, and green. So 4 different options. So we need to check the left and the right-hand limits. So we're going to check as x approaches -1 from the left and -1 from the right. So I'm going to erase what I have here. Maybe you want to make sure you have this all written out because I need some space to finish writing out this problem. All right, so let's start with the left-hand limit. So we want to check the limit as x approaches -1 from the left. So if I were to draw up my number line, if we're coming from the left, I'm looking at a value at like -1.001. If I'm coming from the right, let's do this in green, from the right, you're looking at a number at like -0.999. So from the left, I'll highlight that here in red, this is what we're checking out. So if I have -1 plus 5, well, that's going to be, if I have -1 from the left plus 5, all over -1 from the right plus 1, well, this is still going to be 4. It's going to be very close to 4. But now if I have -1 from the left, oops, sorry, that should be a minus. If I have -1 from the left plus 1, so I really have -1.001 plus 1. That's going to be close to being a -0. So we would say this is a -0. So if I have 4 being divided by a negative number, and it's really close to 0, well, this is going towards -infinity. So the limit as x approaches -1 from the left is going towards -infinity. All right, so again, we just plugged in that -1 from the left. Oops, I forgot my arrow here. This is x approaching -1 from the left. negative 1 from the left. So because I'm approaching negative 1 from the left, again, negative 1.001 plus 1 is going to be close to 0, but it's going to be a negative number. So again, a number divided by something super close to 0 is going to go towards infinity, but in this situation it's negative, so we have negative infinity for this first scenario. Now we want to check the limit as x approaches negative 1 now from the right. So as we approach negative 1 from the right, we're looking at this negative 0.9999. So I'm going to write out here, we have that negative 1 from the right. All over, again, the negative 1 from the right, plus 1. Negative 1 plus 5, that's still going to be about 4. And then I have negative 1 from the right. Well, I have, for example, here, that negative 0.99 plus 1. This is going to be approximately 0, and it's going to be a positive 0, because that difference would be 0.01, and it's a positive number. So I have 0 from the right. 4 over 0, that's always going to go towards infinity. And now because it's a positive 0, this is going towards positive infinity. So this is what my graph would look like as I approach negative 1 from the right. So because we're approaching negative infinity and positive infinity, these are two different values for what the limit is as we approach negative 1. We would say here that the limit does not exist. All right, guys, we are all done. That is everything I wanted to get to show you for our limits unit. I hope you guys enjoyed the year, and congratulations for those of you that are graduating. And my juniors, I will see you next year. All right, guys, I'll talk to you soon. Bye.